Little 1-7 in college algebra today, doing a little inequalities. And the first few are linear inequalities because they're only dealing with x's, no y's, so just one-dimensional. So what we'll do is we'll try to get x all by itself, usually on the left side. So I'm going to distribute that 4 through the parentheses in that situation. And then I like to move my x's over to the left side in that situation. So doing so, I would subtract 5x and get 7x minus 8 less than or equal to -9. Remember, sometimes this symbol has to switch as if you was to multiply or divide both sides by a negative. So I did not do that. Then I want to add 8 to both sides, excuse me. And then, of course, divide by 7. And even though I'm going to get a negative result, dividing by 7 does not switch the symbol because I divided by a positive. So kind of wacky little numbers. To graph it on the number line, I'm just going to put whole numbers. I'm going to go 0, 1, 2, 3, 4, and etc. Please finish your scale out. But we'll decide we want a closed dot right here. And then since it doesn't land on a tick mark, I'm going to literally put this little 1/7 in that spot right there. So, and it was less than, so she goes to the left. Here, what makes him a little scary is there's fractions, so I'm going to multiply it by 10 since that's the least common denominator. So 2 goes into 10 5 times, and then when you take that times the numerator, you have to distribute it through. So that's where this came from right here. The symbol doesn't switch when I multiply everything times 10, but then 5 goes into 10 twice. Taking that times the numerator, you get 36. Then I'll add 25 to both sides. Symbol does not switch when I add 25 to both sides. And finally, divide by the 5. Punching that in to kind of see where we're at. 61 divided by 5 is like 12.2. So that tells me when I want to make my scale, I got to have a 12 on there. And then, of course, I'll finish it all out. And 12.2 is roughly there. It's going to be an open dot, and symbol, and the arrow goes to the left in that situation. So no big deal here. This one, another plain Jane, but what I'm just showing is I think it's better to move the x's to the left side. Like this dude right here and this dude right here say the exact same thing. They both say x is bigger than 2, but doesn't the purple one, isn't it like way easier to read in that situation? So if we move our x's to the left side, I think our brains will be happier. So I will subtract 6x over. And then, of course, we'll subtract 4 in that case. So we'll do that. And here's the case where we got to divide both sides by a -3. So the symbol had to switch in that case. So when dividing by a negative or multiplying both sides by a negative, the symbol had to switch. And then we graph it just like we have before. To solve the double inequality, it's interesting that they call that a double inequality. Most things call it a compound inequality. But here's what we'll do. We're going to cheat. There is a long way to do this and a short way. My short way is going to work for us in this class, but it really only works if the x's are in the middle of this compound inequality. See, there's like 3 different parts to it. If there's only x's in the middle, which that's the way it's going to be for all our questions, we can do a little cheat. So if we just pretend for a second that this wasn't there, like isn't our move to start getting x all by itself to add 5 to both sides? The weird part is there's not both sides to this guy. There is like 3 different places. So what we'll do is we'll add 5 to all 3 places. And obviously you don't need to show these little baby steps, but I'm just showing you like what's going on. There is a left part, a middle part, and a right part. If we add 5 to all 3 places, I get me a 22. The symbol doesn't switch when you add 5, and then that's a 36. And then still trying to get x all by itself, you can just divide all 3 places by 3. So this would obviously come out to be x. The symbols don't switch. That is a 12 in that case, and then this doesn't come out nice. So, but still, this is our compound inequality where you read from the middle in that case. And on this next one, here's a good one. A student's taken 4 tests and has earned these grades. Check it out. They got a 90, an 88, 93, and 85. And in class we talked about, hey, that kid's doing pretty good in class. Those are pretty decent test scores, right? So if all 5 test scores count the same, right? So they've taken 4, they're going to have a total of 5, and they all count the same. Right? What grade must the student earn on the final so that the course average is a B? That means they got at least an 80 and less than a 90. So they want us to do an average. That means we just add them all up. Well, the trick part is we don't know the fifth test score, so what we'll do is we'll let x be the fifth test score. I'd like you to define that by writing it down. So we've got x being that fifth test score, and all I need to do is add up all 5 test scores. So these 4 are simple. Just add them up, and don't worry about changing them to decimals or anything. If you add up 90 plus 88 plus 93 plus 85, you get 356. But see, that's only 4 test scores. I got to add the fifth test score to it, so that's why it's just going to be plus x, because x is the fifth test score. So, cool, I've added them all up. Then, of course, I got to divide by 5 because that's the total number of tests to find the average. So, there's our average right there. It's just kind of weird because we don't know that last test score. But what we then are told is we want to get a B in the class. So, what we do is we'll put some symbols pointing to the left every time. Like if it was an arrowhead, like you see how that like points to the left. Put some symbols pointing to the left to make a compound inequality, and then we throw our boundaries on there because to get a B, there's boundaries. It's got to be between an 80 and a 90, so put your smaller number on the left and your bigger number on the right. But what we've got to go back and decide is if we can put equal to bars, like those bars underneath it. So like if the kid got an 80, doesn't that literally mean like 80 is included to get a B? Like an 80 is a B. It's not a C or anything like that. But if they got a 90 is literally an A. So like there's no reason to put an equal to bar underneath that because if they got a 90 in the class, their grade's not a B, it's an A. So they have to get less than a 90 but greater than or equal to an 80 in that case. So now that we got that all set up, we can solve for x. And this is a giant all over 5, so I'm going to get rid of this, like divide by 5 first by multiplying all 3 places by 5. Symbol doesn't switch when I multiply by 5. And that is 450, right? And then we will subtract the 356 from both sides. So 400 take away 356 is 44. The symbol doesn't switch. X is in the middle. And 450 take that way is a 94 in that case. Right? So this is what's going on. This student must get, you always read from the variable, greater than or equal to a 44 on that final. Like we said, they're doing really good, right? So it's like they got leeway to say, okay, I can kind of mess up on that last test and still get a B. They've got to get a 44% or better. And also, they have to get less than a 94, because what that means is if a kid gets a 94 or better, their grade will actually go up to an A, because don't forget, they're doing really good, you know. So like, it is possible for this student to get an A in the class if they get a 94 or better on the final. Now, when you get to homework, homework's going to only ask you, like, what's the minimum score that they need on this? That would be this dude right here, right? So the minimum score they need is a 44. And then let's get to some two-dimensional guys. It's got x's and y's, so they want us to graph it on the coordinate plane. And I'll bet we feel pretty darn comfortable graphing these if we put them in slope-intercept form first. So let's solve this bad boy for y. So I'm going to subtract 6x from both sides. And the symbol does not switch if I subtract 6x. And then we're going to divide by a -3. So since I divided by a negative, the symbol is going to switch. Negative divided by negative is a positive 2x minus 4. So I would like to graph that dude. It's got a y-intercept of -4, so I'm going to start at -4 and then rise to run 1. Rise to run 1, rise to run 1. And then, of course, it's an inequality, so we have to decide if this line is solid or dashed. Since there is no equal to bar underneath this guy is a dashed line in that case, meaning that line doesn't count. We'll talk about that here in a second. But this just shows like the boundary. We need to find where the solutions will all be. So there's a trick. When you get y all by itself, this symbol of less than means like you can look below the line. So where is below the line? I always say just put like your pencil on the y-intercept, and then if you go below it and like shade down there, you can just lightly shade it with your pencil. But any ordered pair in that like pink region right there is a solution to this inequality. And homework's going to ask us a lot of cool questions. They're going to say, hey man, list 3 ordered pairs that are solutions to this system. So here's a simple one. If you see like 6, 0 is totally in that pink region, 6, 0 is a solution. But let me show you what that means. That means like if I substitute 6 in for x and 0 in for y, I'm going to get a true statement. So like putting 6 in for x, 6 times 6 is 36. Putting 0 in for y, that just goes away. And then the rest of this inequality says greater than 12. Like true or false? 36 is greater than 12. That's totally true in that case, right? So 6, 0 is a solution to this guy. Any of these ordered pairs are solutions. So that guy right there is at 4, negative 3. Remember when you're typing them in the homework, make sure you put parentheses around him, and you got a comma in between. And then this guy, he's in the shaded region, so that's 8, 4. But the interesting questions is points like this. Like, what do you think about this green dot right here who's on the line? It's at 5, 6, but the main thing is it's on the line. My question is, does the line count or not count? And in this case, it does not count because it is a dashed line. So if I put that ordered pair of, this is 5, 6, if I put that in here, 5 goes in for x, so that would be 30. Take away 6, which is let's just forget about that. But if it's just like totally on the line, if the line is solid, it counts. If the line is dashed, it doesn't count. So let's list an ordered pair that's not a solution to the system. Here's an easy one, like 0, 0. It's not in the shaded region. Any of these points that are not in there, like any of these guys, you just pick somebody that's not in your shaded region. But that's just like a two-dimensional like inequality with one scenario. Here's a system of them. So what we'll do is we'll graph one line, shade it, graph the other line, shade it, and see where the shades overlap. So I'm going to kind of speed things up here. I'm going to solve this first guy for y. So you can totally do that. Pause the video if you need to. And the symbol did have to switch when I solved that guy for y. And he's a solid line, and I need to shade him, right? So the shade, since y is all by itself, I can totally read that symbol. That's a less than or equal to, so the shade is going to be like down here. But because I'm going to have to shade another line in that scenario, I didn't like totally make a big mess of it with my pencil. I just said, okay, this line is going to be shaded below. Then when we get to this second guy, we're going to run into a small little weird scenario. I'm going to subtract x over, and then I'll divide by 3. Doesn't switch the symbol. That's going to be a negative 1/3 x. And here's what's weird for people. They're like, hey, man, what the heck just happened? My y-intercept didn't come out to be like a nice, neat integer in that case. That can happen. It very rarely has happened to you in the past. So what we'll do is we'll go to our calculator, and we can just put this equation in. It was negative 1/3 x minus 4/3. Do you see how I put my fractions in parentheses also? That's a pretty good habit. And if we go to our table of values, which is above the graph, hit second table, it will show you all kinds of points on this line. Some of them are really weird, and some of them are really nice. Like you see, negative 1, 1. That's a nice, neat place. So I can go plot that. Negative 1, 1. That's a nice, neat place on my line. Another one that's nice and neat is 2, negative 2. 2, negative 2 is nice and neat, and that's enough to make my line. I just got to take my straight edge and connect them together. The question is, what kind of line will it be? So be careful of that on your homework. Solid line or dashed line. He's got to be dashed, so you'll select the dashed line first, and when you graph it, then you just got to like pick a point on the one side of the line, you know, to where you want to shade. So this guy should be above. So I'll shade this guy above. So and literally that's kind of like all you do on homework. There's nothing that you need to do to indicate that this is the final answer, but on paper you do. I need you on paper to like totally like kind of darken this guy in where the green shade and the red shade overlapped each other in that case. So on homework, I don't think you have to pick the region, but here on paper we will. Then they ask us a couple questions. Is 3, 4 a solution to this system? So 3, 4 is right here. He's got to be in that blue shade, like where the shades overlap. That is not in the blue shade, so that's a big fat no. Is 6, -1 a solution? Here's where 6, -1 is, this purple dot. Yes, he's in the blue shade. I'll make up just a couple more, like is this black dot a solution to the system? And that is a no, because he's on that line, and that line is dashed. But if they gave you a point that was like right here, is this a solution to the system? That is a yes, even though it's on the line. That line is solid. So that's kind of like the long way to do these guys. We'll do that again here. And they say, hey man, graph all 4 of these dudes on the old grid and see where the shades overlap. We're going to kind of go out of order because these two are almost like freebies. It's like x greater than 0 and y greater than 0. Those are horizontal and vertical lines. And like when I graph them, the blue one right here is the y greater than or equal to 0, so I'll like highlight that blue for you. That's this dude right here in blue. You see it's the horizontal line. He's solid, and I shaded above it. And then the red one right here is x greater than or equal to 0. That's the line x equals 0. And then it's solid, and I shaded to the right of it. Right there, I can already tell you, you see where the blue shade and the red shade overlap is in this pink region. These keep you in the first quadrant when you're graphing this stuff, right? So that's kind of the whole point. So I kind of do those first. It's like, all right, when I get my final answer, it's going to be in the first quadrant. So now what I'm going to do is I'm going to take the first equation and just like solve it for y. So if I subtract my 2x over, I get myself this guy. He's got a y-intercept of 5. You go down 2 to the right one, down 2 to the right one. Connect the dots with a dashed line because he does not have an equal to bar with him. Then since y is all by itself, I can like just read the symbol. He is a less than. He's going to be shaded below that green line. So all of this is what's kind of going on, but I really don't need to shade all that in because remember, we're staying in this pink region, so honestly, isn't just this little triangle so far like our area that is going to be going on. So I know somehow, some way, my final shade is going to be restricted to just this. It's got to be below this green line, but also make these two true, which kept me in the first quadrant. Problem is, I've got a fourth line that I need to graph, so I didn't get too shady yet with this scenario. So to graph that fourth dude, I'm going to solve for y, so I subtract the 2x over, and then there's a negative y right there, so I need to like divide everything by a -1, and that switches my symbol in that case. You can kind of see I only have that little green triangular region so far because I know my answer's already got to be in there. So when I try to shade under this purple dude right here, you see it is a less than, so I'm going to go below it. That would keep me below that purple line, but also in the green shaded region. So you can finally take your pencil and really like kind of darken in, here's our region, which is hard to see, so I'm going to blow it up a little bit for you. It's got to be to the right of that red line, above this blue line, below that green line, and below that purple line in that case. And when they ask us to find the corners are just the vertices of this guy. So like I'm going to put some big fat dots right here. Here's a corner, here's a corner, here's a corner, and here's a corner. And I'll show you why here. So I put these vertices in there, A, B, C, and D, and I just like kind of made this like polygon really, really large. You don't need to do that, but what I'm just showing you is that feasible region, like that orange shaded in thing, is totally a quadrilateral, so it should have 4 vertices in that case. So like I said, you don't need to put all those guys. But I do like calling them A, B, C, and D so we can see who's who. A is at 0, 0. That's pretty basic right there. B is a weirdo, right? B is in no man's land because he's not literally on that tick mark. So we're going to like come back to B. But C is at 1, 3. And D is at 0, 1. Make sure we like totally put those in parentheses when we're typing them into homework. But where's B at? We're going to have to solve a system for B because B is totally where this green line, that's why I kind of color them, that green line and this blue line, which is this dude, that's where those two intersect each other. So we're going to have to solve a system with those. And the easiest system that I think to solve these is what? Substitution, because if I just change these to equal signs, this one right here literally says y equals 0. So I already got that taken care of. I just got to substitute 0 in for y into that other equation so I can do the algebra and solve. So I'll subtract my 5 over. And then I think getting a decimal makes a whole lot more sense on this than putting in like 5 halves in that case. So B is at 2.5, because that's what we figured out for x, 0. So what, again, I had to solve a system when they didn't land on a nice, neat grid mark. I had to just say, okay, what two lines intersect there, and solve that system. So that was kind of weird. If you need help with that, why don't you come on in and talk to us, and we'll help you, whoever your college algebra teacher is. But that's kind of like the full way to solve this system with more than one line and all that stuff. A lot of times they've already got the work taken care of, right? There's 5 lines in this situation, right? But the cool part is they already got them graphed. So I got a little different way to do this, since we don't have to like literally get y by itself. The point of why we got y by itself is so we could graph the lines. But they already got that taken care of. So check it out. We're going to take care of those first. Boom. You see, like those two dudes right here, they make our feasible region, that shaded region, like in the first quadrant. So I know my final shade is going to be in this pink zone. Then I'm going to go one line at a time right here, and I'm going to do a new little trick, right? So if I focus on this line right here, which is actually graphed for me already here in green, right? They got it solid, but I just need to know where should I shade, above it or below it. The problem is that other trick of just reading the symbol doesn't work unless y is all by itself. So what we're going to do is we're going to use a test point. We're going to test any point to see if it makes a true statement or a false statement. Like, for example, like I could test this point of 4, 3, and if it was true, that means we shade in that region. If it was false, it's not. Well, 4, 3 means I got to do a lot of math. I'm going to test 0, 0, dude. 0, 0 is an easy point to test right here, because that means I've got to substitute 0 in for x and 0 in for y. Well, what's cool about doing that is those numbers just multiply out to be 0 every time. So this inequality will literally turn into 0 on the left side. The symbol is less than or equal to negative 55. And what you have to decide is, hey man, is that a true statement or a false statement? Is 0 less than or equal to negative 55? And that is false. So what that means here is I could shade on either side of the line, right? Here was 0, 0. We had 0 less than or equal to negative 55. If I shade on either side of the line, like since this was false, right, you know, like this green shaded region, that's where 0, 0 was, and it's a false point, that means that's not where it needs to be shaded, which is below that line. A lot of people are like, well, how did you know that? 0, 0 is below that line, and that doesn't work, right? It was a false statement, so that means the blue shade has to be the correct guy in that case. So it's going to be shaded on this side of the line in that case. So 0, 0 like didn't work, so we're going to shade on the blue side of that line. Right? Then we got to do that all over again with this dude right here. Let's use a red highlighter. I got to see where I'm going to shade on relation to this guy right here. This line, I could either be above it or below it. So let's test 0, 0. If we test 0, 0, we're going to put 0 in for this and 0 in for that and see 0 less than 1. True or false? Is 0 less than 1? Well, this time that's true. So since 0, 0 is below that line, I'm not in the yellow region. I'm into the green region in that one. So that goes away, and we have just kind of restricted ourselves to the green region. So here's where we're at so far. I know I needed to be in the pink region, and I know I had to be over here, but out of all that green stuff, this area is worthless because it's already on the wrong side of that original line, so I'm restricted myself to here so far. It's like, all right, we're going to be over there, and there is a third scenario where I got to check this guy, right? So I got to check to see, let's test 0, 0. That's going to turn this out to be 0, 0 less than 72. So here's 0, 0, and we're checking it on this line right here. is 0 less than 72? Because I'm either going to be in this red shaded region or this orange shaded region in that case, depending on those two, if this is true or false. This guy is true. So where is 0, 0 in relation to this red line? He is below it. So that means I want to shade below it in that case. But I'm going to use the other three parameters to just kind of say, hey man, it's like I need to be below this line, but it's still got to be going on and all of that. So the final shaded region, it kept me satisfying these in that pink zone. It kept me satisfying this in that blue zone. It kept me satisfying this. It's got to be on that side of the line. And then it kept me satisfying this. So that's kind of weird, man. Let's try another one of those and see if you like it. Oh, where's the corners at? So boom, 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 boom. Those are the four corners right there at 4, 5, 5, 6, 11, 0, and 12, 0. Now let's try another one of those and see if you like it or don't like it. Here they got a parabola guy. And here they got a linear guy, and they just like ask us to shade the final region. So on the parabola, you can either be on two sides of it. You can be inside the parabola, which is like in the green zone, or you can be on the outside of the parabola. Let's see if we test 0, 0. Here's 0, 0. Use a different color, Mr. Monosil. Here's 0, 0. And let's see what happens when I substitute 0, 0 in. This becomes 0. The symbol is a less than. Sorry about that. The symbol is a less than. And there's a 4 in that case. True or false? Is 0 less than 4? That's true. So that means, where is my purple dot? He's in that green zone, and it was true, so that's where I want my shade to be. I want to be in the green zone, right? Because 0, 0 is true, so he should be in the shaded answer for this parabola. Then we got to try it again for the line. If I put 0, 0 in here, 0 less than 4, that is also true, right? So where is this purple dot in relation to this line? He is below it, so that means I need to shade below that line in that case. But I really care about where the orange and the green like overlap each other in that case. But since this was true and he's below it, we're going to shade that. And then the final overlap is right there. But here's what I told everybody. It's like, man, if you don't like that test point thing, that's totally cool. Then just solve everybody for y. Just solve each guy for y, and then you could read the symbol. For this parabola, it's like, okay, that's a greater than. So that means you've got to go to the vertex and shade above the parabola in that case, right? And then on the line, get y by itself, and that's a less than, so you shade below that line. Like the old school way of doing it, of getting y by itself, is always going to work. I just thought for some people, maybe you could try the test point thing and you like it. If you don't like it, totally fine, man. So, man, let us know if you need help with that. We will help you. So, thanks, and have a good one.